So today we're going to see a short topic, a very important dental cement in detail about zinc phosphate, which is one of the most important and it is the oldest dental cement. Okay. So going on to zinc phosphate now. The contents of today's class is going to be, we are going to see a brief introduction. Then we are going to see what is a definition of a dental cement. Then we are going to see in detail the classification of dental cements. Then in detail about the composition of zinc phosphate, what is the setting reaction of zinc phosphate, what is the mixing time, what is working time, and what is the setting time of zinc phosphate cement. Then we are going to see in detail how we are going to manipulate or mix the cement. Then we are going to see about the physical properties, we are going to see the biological properties or the biocompatibility of zinc phosphate cement. Then in detail about the clinical applications and the uses, and then the advantages and the disadvantages of zinc phosphate. Coming to the definition of a dental cement, so there are two definitions which you have to know. One is from Textbook of Dental Materials by Anusavis, other one is a Textbook of Dental Materials from Craig. Okay, so a dental cement can be defined as a substance that hardens to act as a base, liner or a filling material or an adhesive to bind devices or processes to the tooth structure or to each other. So that is the definition from Anusavis. So in simple terms, dental cement is a substance which is used for filling the tooth structure. It can be used as a filling material itself, or sometimes it can be used as a cavity liner. Supposing it's a deep cavity, it can be used as a cavity liner, or if it is a shallow cavity, it can be used as a cavity base. Or dental cement can also be used to as a luting cement, in the sense it can be used to bond an inlay or an onlay or a crown to the particular tooth structure. So that is the, so depending upon the use is your definition. Okay. So then coming to the definition from Craig, it is a non-metallic material used for filling, luting, permanent or for temporary restorative purposes, made by mixing components into a plastic mass that sets as an adherent sealer in attaching various dental restorations in and around the tooth. Okay, so that is the definition given by Craig. So in simple terms, it's same. It means the same. So dental cement is obtained by mixing two components. When you mix two components, you are going to get a material. So depending upon what use it is, whether it is going to use for luting. Luting is to fix your inlays, onlays and crowns to the particular tooth. So that will be in a thinner consistency. A restorative consistency will be like a thicker consistency that is mainly used as a permanent restorative material or as a temporary restorative material. So that is the definition about the definition of a dental cement. Okay. So now coming to the history. So the history gives you the years in which each of the few important cements were introduced. So all this you need to know into detail from the exam point of view. So first is an amalgam introduced in 1833. Then coming to zinc oxide eugenol, which is introduced in 1858. Then coming to zinc phosphate, which is introduced in 1879. Then 1908 is your silicate cement. Then 1936 is your calcium hydroxide. 1947 is acrylic resin cement. 1958 is your reinforced zinc oxide eugenol. 1962 is your composite resins introduced by Dr. A.L. Bowen. And in the year 1968, you have your zinc polycarboxylate cement, which is again got chemical addition to the tooth structure. And 1968 by Wilson and Kent, GAC was introduced. This also has got a chemical addition to the tooth structure. And GAC is also has got an anti-kerogenic property because of its release of fluoride. Now, what are the ideal requirements of a dental cement? Any cement has to fulfill the following requirements so that it is most ideal as a restorative material inside the oral cavity. So, most important, it should be strong, it should be hard, it should be insoluble in saliva, it should be dimensionally stable, it should be adhesive, it must be non-porous, it must be biocompatible, it must be non-irritant. The coefficient of thermal expansion should be equivalent to that of the tooth structure. It should not be affected by thermal changes or moisture. Most important, it must be easy to manipulate. Coming to the classification. Based upon the setting reaction, so there is one classification in Anusavis textbook of Dental Materials by Anusavis. So this gives you one classification based on the setting reaction. So first one is a acid-base reaction. You can classify the cements based on that. So as is zinc phosphate, you have your zinc polycarboxylate, then there is your zinc oxide eugenol, then there is your glass ionomer cements. All these four cements falls under the class under the category of setting by an acid-base reaction. Then you have the chemical or light activated polymerization, that is you have to show either both chemical or light. That is, some materials it will be available as a base paste and a catalyst paste. You mix both the cements together, so it sets by a self-cure reaction. And additionally, you can show your light curing unit, okay, your quartz tungsten halogen or your LED light curing unit, and you can polymerize it, okay, or you can harden it, okay. So based upon that, you have your resin modified glass ionomer cement. You also have your compomer. Compomer is nothing but a mixture of your composite and your GIC, okay. Coming to the light activated polymerization setting reaction, that is mainly, as you know, already know, it is your composite resin restorations which sets by your light activated polymerization. You have to show your visible blue light depending upon whatever the light curing unit you are going to use, and it sets at that particular wavelength, which is your 400 to 500 nanometer, you get your hard composite mass. Another classification is given in textbook of dental materials by Craig, which is based upon the chemical composition. So, based upon the chemical composition, you have your water-based cements with nothing but your GIC, you have your resin modified GIC, then you have your zinc polycarboxylate cement, then you have your zinc phosphate cement, then you have your resin-based cements, you have your composites, you have your compomer. Compomer, as I already told you, it is a mixture of your composite and your GIC, glass ionomer cement. Oil-based cements is nothing but your zinc oxide eugenol. Eugenol is nothing but your clove oil, okay. Then your non-eugenol cements also you have your cavity varnishes, okay, nothing but your copal, resin and rosin, which is dissolved in your solvents like ethanol or ether, that is nothing but your cavity varnish. And you have your cavity liners which are placed in very deep cavities, mainly your calcium hydroxide, which is used as a cavity liner because it has got the ability to stimulate the reparative dentin formation. Hence, you use your calcium hydroxide in deep cavities as a cavity liner. Then you also have your zinc oxide eugenol cement. Okay, zinc oxide eugenol cement is also very rarely used as a cavity liner because of its obtudent effect, that is a soothing effect on the dental pulp. Okay, then you have your high strength bases.